Okay, good morning class.
Good morning, sir.
So today we're looking at the exercise 9.5, the second half of the exercise, correct?
Yes, sir.
So now we're looking at numbers 4 to 4 to okay. People, please, if you don't mind. No? Okay, so here we are told that given the BDC, BEDC is a cyclic quadrilateral. BEDC. So this is cyclic quad, what do we know? We know that opposite angles are supplementary, and the exterior angle is equal to the interior opposite. Okay, and of course that is also supplementary and so on. Okay, then we are told that with DE produced to F, ED produced to F, B is parallel to CD. People, if these lines are parallel, what do we know? Alternate angles are equal. There's no alternate angles corresponding, so that angle is actually equal to that. That angle is also equal to that. Co-interior is 180, and then that side is 1. Okay. A is a point of the circumference of the circle, and BA and DA are joined. Those lines. Prove that B2 is equal to E. People are just deep there. Come on now. Why do they make it so easy for us? No? Yes, Donna, your hand is up? It's still up? Oh, now it's not up. Alright. So let's go. How do we start off? We always bring our X into it. Not so? It's the best part of our life. No? So we say let B2 equal, or you could let E equal X. Not so? Now what? Which other angle will be X? D1 is X. Why is D1 X? There's going to be exterior angle of cyclic quad equals the interior opposite angle. Alright, now what? Which angle is equal to X now? E. So angle E is equal to XY. Corresponding angles with PE being parallel to C. Say, therefore, B2 is equal to angle E, which is equal to. Any confusion there? Yes. Sorry? There should be. Tell me, what did you do? So where did you start? You let this be X. B2 is X. Okay? Then you say 180 minus X co-interior. Yes? And then X here. Opposite angles of cyclic quad. Beautiful. Nice. You all agree with that? I think that's easier. No? It was the same. Okay, they don't want me to feel bad. People, let's look at B. D1 is equal to angle A. But D1 is what? Already X. So if I can prove that angle A is X, I've done my job. Not so. But angle A is X. Why? Angles in the same segment. Didn't see that? Nice. So angle A is equal to X. The reason? Angles in the same segment. It's coming from arc B D. Do I have to write the story here? No. And the job is done, people. Therefore, angle D1 is equal to angle A, which is equal to X. Now that girlfriend there, she didn't use this one. So she's first going to prove that D1 is X. She wants a lot of X's in her life. Only a joke, no, that may be late. So she didn't get this one yet, so she first had to say that D1 is x corresponding, and then angles in the same segment. Huh? Because she was went down this route. She didn't pick up D1 in her solution. In A. Okay. Right? Any confusion here? Huh? No. Let's look at number 5. Number 5, given that A, B, C, D is a cyclic quad. People, if A, B, C, D is a cyclic quad, what do we know? Many things. We know that? B1 and 2 and D1 and 2 adds up to 180. Why? Angles in the... No. Opposite angles of cyclic quad. We also know that there's ABD plus BCD is 180. Opposite angles of cyclic quad. There's no... Oh yeah, we can go with angles in the same segment. Those angles are equal. That one is equal to that. Not so. Likewise, this angle here is equal to this one here. And this one is equal to that. Not so. Then we are told that with AB equal to AD, if AB is equal to AD, then that and that marking is the same. Not so. And BC is equal to DC, which makes these markings the same. Not so. Prove that AC is the diameter of the circle. AC is the diameter of the circle. Now, the question we should be asking ourselves, if AC was, it is not, no? Listen nicely. If it was the diameter, then what can we conclude? That B1 and 2 is 90. Or D1 and 2 is 90. Not so. If that was the diameter. Is it the diameter? No. So what we're going to prove is we're going to prove that D1 and D2, B1 and B2, the combination thereof is 90, or D1 and D2 is 90, one of the two. You guys understand? If that is 90, then this has to be the diameter. Okay. So I'm using that angles in semicircle in reverse. Then they tell us the story that B1 is x, we let B1 x, let B2 y. So do I have to say, let B1 be x? No. Why? Because they tell us that already. Verstaan julle? Right. So which other angle is equal to x? D1. So you say D1 is x. Why? Angles opposite equal sides. Right. Is there any other angle equal to x? This one here. Not so. But we'll see later if we need it. Okay. Which other angle is equal to y? D2 is equal to y. Why? Angles opposite equal sides. And which other angle is equal to y? This one here, not so. So, what I can do is I can say, okay, this is x and that is y. Then I can say x, y plus x plus y plus x equals 180. Can you see that? Then I can work out what is the value of x and y. Or, I can say, hang on, x plus y plus x plus y is equals 1 y. Opposite, not the angles are the same, no. Opposite angles are cyclic quad is supplementary, not so. What's x plus x? Not x squared. Okay, you guys know that, no? Y plus y equals 180. But what do we have here? X plus y. So how do I get x plus y here? Zoe? Doesn't look like you're busy with your maths. You am, okay? I hope you am. Right, so what do I do here? Divide by 2. The first time I see you so interested in what you're busy with it. You're in the writing, okay? You didn't do that work. Oh, you're writing good. Okay, nice. You're getting clever now, see? Right, so 2x divided by 2? X. 2y divided by 2? Y equals 90. That's it. Can you see this is now 90? I was going to say this. But not this time. Because you said it right. So we got now, as you can see, x plus y is 90. So we say since what? A plus B, A angle ABC is equal to 90 degrees. Not so? So therefore AC is a diameter. Why? Converse of angles in a semicircle, or 90 degrees subtended by chord. Okay. Verstaan julle? There's quite a bit of marks here. 2, 3, 4, 5, 6 marks on something like this. It's only if you want it, no? And most of us? Yes. Keep on lying to yourselves, no? But learn this, people, is worth it. Worth the time spent on it, okay? You see now why geometry is my favorite? After trigonometry and graphs. Okay, all is my favorite. Right? People, given ABCD is a parallelogram. People, if ABCD is a parallelogram, what do we know? Alternate angle. Opposite is a parallelogram. Opposite angles are equal. Opposite sides are equal. Opposite sides are parallel, yes? Or is that why she's saying alternate? Nice, okay, understand. What else? Diagonals bisect each other, but there's no diagonals here, okay. Then we are told that is a point on AD such that DC is equal to EC. People, if that's the case, what do we know? D2, angle D is equal to E2. Why? Angles opposite, equal sides. The question says prove that A, B, C, E is a cyclic quad. How do we prove cyclic quads? One of three. What is it? The bow tie. And then? Exterior angles equal to the interior opposite. And then? Another one. Opposite angles are supplementary. We can prove any of these three. It will be a cyclic quad. Not so? So if we look here, what do we see already? If this was a cyclic quad, then that angle would have been equal to that angle. So to prove it's a cyclic quad, we prove that that angle is equal to that. And there it's already marked. Not so? So now I just need to lay it out nicely. Not so? Also in your exam, people, you will get a diagram sheet. Not so? Use the diagram sheet. Okay, the diagram is on your answer book. Yeah. Don't. If you want to write on the answer book first. So when I mark, then I check your diagram. Sometimes these marks get awarded there as well. Yeah. Right, now you know. Right. People, where do we start? So firstly, we know that we're going to prove that angle D is equal to E2. So where do we start? We say let angle D is equal x. Right, now x is back in the game. Now what did we do with the x? Gave it to? Huh? E2. E2 is equal to x. Why? Angles opposite, equal sides. So x lies there. C1. C1 is x, yes? Why? Alternate? Yes. But how's that going to help us in our course? It's not going to help us. A. How?
So, you say that ABC is equal to S.
A,
BC.
B, oh, ABC
No, sir. ABC.
is X. Angle B is X. Yes, why?
Exterior angle.
Okay, just a second. Hold that thought, just a second. She says angle B is equal to XY, exterior angle of cyclic quad. Is that what you're saying? Hello. Now, is this a cyclic quad? Not yet. We didn't prove it's a cyclic quad yet, or they didn't tell us it's a cyclic quad. We have to prove it's a cyclic quad. So we can't use the properties of the cyclic quad to prove a cyclic quad. You understand? So we can't use the fact that that is. But D is equal to EY.
Opposite angles are equal.
There we go. Angle B is equal to X. Opposite angles are equal in parallelogram. So hang on. You hang on. Yes. So what do I write? Since, yes, angle E2, we state the obvious. E2 is equal to B is equal to X. Therefore, now we answer the question. AB, CE is a cyclic quad. Why? Exterior angle equals the interior opposite. Okay. 1, 2, about 3 or 4 marks here on the side. Easy, no? Can't get easier than this. At least number 7 is easier. Let's see. Ay, why so much lines? A lot of lines make it easier. Right? People, we are told that KLMN is a cyclic quadrilateral. So KLMN. People, if this is cyclic, what do we know? Many things, he says. Yes. But of the many things, name it. Opposite angles are supplementary. So that plus this equals 180. What else do we know? Is there an exterior angle for that quad? No. What else do we know? The bow tie, yes. K2 is equal to L2, and N1 is equal to M1, and N2 is equal to and. Okay. Right. What else do we know? We are told that KL, KM, and LN are joined. T and S are points are LN and KM, respectively, which means say in that order. Then we are told that KN is parallel to TS. People, if KN is parallel to TS, what do we know? Alternate angles are equal. Not so. So N1 is actually equal to T1. But N1 was also equal to M1. Not so. Why is this equal? Bow tie? Alternate. No? So there already what do we notice? Eh? That is equal. So what can you say about the squad? Exterior angle is equal to the interior opposite. So what can we name the squad to be? A cyclic. And please don't ask us that question. We want something more challenging. Right, let's read on. Come on. It says LTSM is a cyclic quadrilateral. Okay. People, you guys can do this. No? Better than what you did in the first control test. Right, so where do we start? Remember, we're going to try and prove T1 is equal to M1. Where do we start? Will it? Will it? What one? There's many ones there. You can't say angle 1, there's an angle 1, there's an angle there. M1. So we say let my one is Bx. Right. Right. So which other angle is equal to x? N1 is. So N1 is equal to x. Why? Angles in angle in the same segment. And it's going to become arc. Arc what? KOKR. Okay. Then what? T1 is equal to xy. Alternate angles. So T1 is equal to xy. Alternate angles with TS being parallel to KM. So hang on. What do we notice now? Since T1 is equal to M1, we state the obvious. Since T1 is equal to M1, which is equal to X. Therefore, LTSM, we answer the question, LTSM is a cyclic quad. Why? Exterior angled equals the interior opposite. And there we go. Job done. Yes?
Can you say M1 equals L2 so
M1 is equal to L2. Why? Co-interior. How do you get co-interior? Does that look co-interior to you? Huh? L, yes? K, L, N. Wait. You're too fast. You make out what you're talking about. Right. So you say I must start K? L? L, there's not another L. K, L, M. K, L. Give it a chance, I don't know what you're talking about. K, L. You're talking about the C. I don't know where's the C. Co-interior. So K, L, A, like that. But are these lines parallel? But how can you use the U, my girl? When can you use co-interior? Lines are parallel. When you're going to use alternate? Lines are parallel. When you're going to use the other one? Lines are parallel. You understand? It's only when lines are parallel. Okay. Anything else? Easy, no? Right, so that brings us to the end of exercise 9.2.